Hello everyone. Hello grade 10. Hello everyone. Hello grade 12. Today we'll be talking about sequences and series. And we also talk about sigma notation, that is the sum of the terms. So we'll just do a recap of what we have learned previously on our previous lesson. All right. So remember the first chapter in grade 12, it's sequence and series. So you must understand the basic terminology. So knowledge and skills for this topic was just doing a recap of what we have learned on our previous lesson. So a basic understanding of algebra, including the manipulation of algebra expressions, equations, and inequalities. A working knowledge of simultaneous equations, a working knowledge of exponential theory and equations. That is, you must be able to work with expressions of exponential and also exponential equations. Then you must be familiar with quadratic equations, solution both by factorization and formula. A basic knowledge of logarithms and how to use logs to solve simple equations. So remember that arithmetic, geometric, and quadratic sequences and series are part of your exam, the final exam, and they were taught in grade 11. So a variety of questions will be asked, which will include knowledge and routine procedures, complex procedures, and problem solving. Determining the summative formula is examinable. So arithmetic and geometric sequences. Your success in this topic will be based on your ability to recognize and categorize the sequence as arithmetic or geometric, and then to select the correct formula and algebraic tools to solve the problem. All right, so this is just an explanation that this side we have an arithmetic sequence and on the right hand side we have a geometric sequence. So the first term is always a, that is t1. Then t2 is a plus d. Then t3 is a plus 2d. Then t4 is a plus 3d, and so on. So so a is the first term and d is a common difference. So by definition, d is equal to t2 minus t1 is equal to t3 minus t2. So this is an example, you can go through it later. Then the general form or nth term is given by the formula Tn is equals to A into A plus open brackets n minus 1 into D. So A is the first term T1, D is the common difference, and N is the number of terms, or is the term number. Then let's go to geometric sequences. So geometric sequences with A as the first term, and we have a common ratio or constant ratio based on your preference. You can either refer it as a common ratio or as a constant ratio, it doesn't matter. So R is equals to T2 divided by T1 is equals to T3 divided by T2, and so on. Examples of geometric sequence, you can just go through this. That is R is equals to T2 divided by T1. In other words, its successive term divided by previous term. Then this is the general formula for the geometric sequence. We have Tn is equals to AR to the power n minus 1. A is the first term, T1. R is the common or constant ratio, and n is the term number. So that is represent the number of terms. So now let's start series now. All right, let's get started. Here we have a sequence. I hope you can see my screen. So here we have this a sequence is given by, so a sequence given as Tn we have Tn is equals to 2n plus 3. So if let's say you need to write this as a sequence, so you will say you just substitute n with 1, then here you have 2 plus 3, which will be 5. Then let's say you're writing the first 3 terms or the first 4 terms, then you substitute n with 2, then you have 2 times 2, that will be 4, plus 3, that is 7. Then here we have 9, 11, and the sequence continues. So if you want to write it as a series, a series given as, remember when you talk about series, you put the plus sign. Here we're talking about the sequence, so it's just a semicolon separating the numbers. So when I talk about a series, it's gonna be a plus separating the numbers. So if you write this as a series, it's gonna be 5 plus 7 plus 9 plus 11. Then the series continues. And also you can write it in sigma notation. In sigma notation. So write it in sigma notation as, here we have Tn. Here we have Tn here. Here we have Tn. Then here we'll have n is equals to 1. The reason say n is equals to 1 in this case, because we started by substituting 1 here and we got these values up to 4. So n is equal to 1. Then here we put the number of terms. Then now remember Tn is equals to this expression. So here we'll have, instead of Tn, we'll just left with 2n plus 3. So we have written this in sigma notation. We have written it as a sigma. So now let's say we're given this problem. So we're given an arithmetic sequence, as 7 is to 2 is to negative 3. Then the sequence continues. So now the question says, calculate the sum of the first 18 terms. So calculate the sum of the first 18 terms, right? So what we need to do here, you just need to figure out the value of a and the value of d, because this is an arithmetic sequence. So by observation, a is always the first term. A in this case is is 7. So the value of a is 7. Then the value of d, common difference. So d is successive term minus previous term. So is t2 minus t1. So d will be equals to negative 5. So the value of d will be equals to negative 5. Then now we have a formula for the sum of terms. We have a formula. So the formula is like this. Sum of terms is equals to n over 2 is equals to n over 2 n over 2 is equals to n over 2 into 2a plus n minus 1 times d. So this is a general formula for calculating the sum of an arithmetic series. So this is a general formula. So you just substitute the values. So Sn is equals to, so the value of n is 18. Remember, the question was saying calculate the sum of the first 18 terms. So the value of n is 18. So it's going to be 18 divided by 2. 18 divided by 2, open brackets, 2a. So it's going to be 2 multiplied by the value of a. The value of a is 7 plus n minus 1. So remember, we have 18 minus 1. N stands for 18 in this case. So times, so it's going to be plus 17, right? Times negative 5. Then now you just use your calculator to get to the answer. So Sn, the sum of the series will be Sn is equals to, so if you use a calculator, it's going to be negative 639. So this is just the same as the general term, but now we calculate the sum of the terms, and we're given that the number of terms were 18. Then you substitute, then we had only one known, which is Sn. All right. So now let's continue with this problem. Number 2. This one were given in sigma notation. We're given it in sigma notation. So we have here 27. Then here we have n. N is equals to 1. So which means the first term, we have to substitute 1 to get the first term. Then we have here 3n plus 4. Okay, so the question says calculate the value of, so we'll calculate the value of this sigma notation. Calculate the value of, so the last term is 27 and the first term is 1, so we have 3n plus 4. So what we need to do here, if you have noticed here, we are given the last term. The last term is 27. So if we are given the last term, we have to shorten this equation. We shorten this equation. We shorten this. we shorten this formula, so it's gonna be Sn so it's gonna be Sn is equals to n over 2 into a plus l. So here is gonna be Sn is equals to n over 2 n over 2 into a plus L. So you only use this formula if you are given the last term, but if you are not given the last term, you use this one. So here we have the value of n. So n is equals to 27. N is equals to 27. Remember, this is the general form, so it's n on top, then n is equals to 1. N can be any number, but in this case we are saying that the number of terms, they start at 1. The number of terms start at 1, then now we have this expression. So here we have n is equals to 27, that is the last term, and a is equals to the first term. In this case, the first term, we're going to substitute. How can we get the first term? So here you are going to say Tn so you want to get the first term. So remember, our formula says general term Tn is equals to a plus open brackets n minus 1 into d. So but now we want to get the first term. So if we want to get the first term, remember Tn in this case is equals to 3n plus 4. That is the value of Tn. So the general formula or the general sigma notation is like this. Tn, it's always like this. So now we take this as a Tn. So we say Tn is equals to 3n plus 4. So T1 now, T1 will be 3 into 1. 3 into 1 plus 4, that will be 7. So T1 will be 7. So here we have the value of A as 7. So we have everything. So now let's start by substituting. So how can we get the last term? How can we get the last term? So as we have done, so remember we have this equation, Tn. In this case we have Tn so Tn is equals to 3n plus 4. So for number 2, the general formula, Tn is equals to 3n plus 4. Then now, since we're going to use this equation because we're given the last term, since we're going to use this equation, you have to find first the value of a. We've got the value of a by substituting T1 in this general formula. Then now, in order for us to get the last term, we have to substitute 27, right? So we'll have T27 is equals to Then we substitute where there's n, we put 27. 3 into 27, right, plus L. So what is the value of L? 3 into 27 plus 4. Plus 4. So you can use the calculator. Then you get an answer of 85. So now we have the last term as 85. Then now when you substitute to this equation, to this formula, so n is 27, right, divide by 2. Then now a, the value of a is 7. Then L is 85. Then you put this in a calculator. Then your answer will be 1242. So Sn will be equals to 1242. All right. I'm just gonna give you maybe 2 minutes or 3 minutes. Welcome, Sister David. All right. So I'm gonna give you just a task to complete. Just for 2 minutes. So I'm gonna give you an exercise. Here we have we have 23. Then we have n is equals to 1. Then we have 5n minus 1. So now determine the first term T1, the last term T23, and the sum of this series. So determine the first term, T1, determine the last term, and determine the sum of this series. The sum of this series. All right, I'm giving you just 3 minutes to complete this task. All right, time's up. So now let me solve this one. Okay, here you are given this series. We're given the last term. The last term is always at the top, the last term. And where you're gonna start the number of terms n is equals to 1 is at the bottom. So what you have to notice here, it does not necessarily mean that n should always start at 1. That is not the law. It can start anywhere. So then we have this general term, general form. So here, determine the first term. Okay, what you need to do here, we have to substitute. Remember, okay, let me write this for you. So here we always have Tn. So here we always have Tn, the general form. Then here n is equals to 1, but n can start, in this case n is equals to 1. Then we have the number of terms, where the terms will end. This is where your term will end. So now, 5 minus 1 is equals to Tn. So then you write Tn is equals to 5n minus 1, right? So now substitute the value of n. In this case, we want the first term. So we'll say, so on this general term or general form, we have to substitute we substitute n as 1. So we'll have T1 is equals to 5 into 1 minus 1. So T1 is equals to 4. So we've got the first value, T1 is equals to 4. Then the second question says the last term, the last term. So for you, in order to determine the last term, remember, we have this general formula. This is our general formula. And we are told that the number of terms in this case, they will end at 23. So we have T23 is equals to 5 into 23 minus 1. So now you just have to multiply 5 by 23, then you get the last term. So L last term is equals to T23 is equals to T23 is equals to, so it's going to be 5 multiplied by 23 minus 1 is going to be 114. Then the last question says, determine the sum of this series, the sum of this series. So now remember, we have the two equations here. The first equation is Sn is equals to n over 2 into 2n plus n minus 1 times d. But when you are given the last term, when the last term is given, Sn is equals to n over 2, n over 2, n over 2 into a plus l plus the last term plus l. So now we just need to substitute. So n is equals to 23 over 2 multiplied by the value of a. The value of a is 4. The value of a is 4. That is the first term. Plus 4 into 4 plus the last term 114. Right? Now you just use your calculator to get the correct answer. So Sn will be Sn is equals to 23 divided by 2 multiplied by 118. 118. So Sn will be 1357. That would be the value of Sn. I hope you are following. So I'm gonna give you another task again. So you must know that math is about practice. You have to practice it. If you don't practice, you will think you know, although you don't know. So it's all about practice. Get used to practicing. Do the exercises. So I'm gonna give you this task. Then we're gonna do. All right. Welcome. I hope you can see my screen. So we just completed this exercise. We just completed this exercise. We're given this sigma notation. So we have n represent the last term. We have n is equals to 1 in this case because we said we start with 1. Then we have tn. Tn is any expression that is here. This represents Tn. Then the question was to determine the first term. So if this is Tn, so you're going to substitute 1 into n, then you get the first term. Then this is what we did. Tn is equals to 5n minus 1. Then we've got the value of a, the first term, as 4. Then now we're asked to calculate the last term. So remember, n is equals to 3, n is equal to 23 represent the last term in this case. So now we're going to substitute 23 into this equation. Where there's n, we put 23. This is just what we did. Then we got the value of 114. Then now we were told to calculate the sum of this series. The sum of this series. So we have a formula. The formula, if we're given the last term, Sn is equals to n over 2 into a plus l if we're given the last term. But if we are not given the last term, Sn is equals to n over 2 into a plus 2 plus n minus 1 times d if you're not given the last term. All right, so then all right, now I'm gonna explain about the geometric series. So the geometric series is an easy one. So we have geometric series. We have a formula for geometric series. Sn is equals to a into r to the power n, r to the power n minus 1, close brackets, over r minus 1, over r minus 1. So here r should never be equals to 1. These are restriction. R should never be equals to 1. So r should not be equals to 1. R should not be equals to 1. So this is a geometric series. This is a geometric formula for a series. If we have a series of A is to this applies if we have a series of A is to AR is to AR squared, AR squared is to AR squared is to AR cubed is to AR cubed, and it continues. So this formula applies if we have a series of this, right? So now let's just have one problem. So we have number 3. Number 3, use a formula to find the sum of the first 7 terms of the series. Use a formula to find the sum of the first 7 terms of the series. All right, here we are given this series. We're given the series 1 over 81, 1 over 81, 1 over 81 plus 1 over 27, 1 over 27, 1 over 27 plus 1 over 9 plus 1 over 9, and the series continues. The series continues. So here, first things first, you have to determine the value of A and the value of R, because we're going to use this formula. Remember this formula? We're calculating the sum of the first 7 terms of this geometric series. So Sn is unknown. So Sn is unknown. Sn is unknown. Then what is the value of A? The value of A is always the first term of the sequence. The value of A is given as 1 over 81. The value of A is 1 over 81. Then what is the value of R? The value of R. So R is equals to successive term divided by previous term. So R is equals to, so our successive term here is 1 over 27. Okay, let's say it's 1 over 9, 1 over 9 divide by 1 over 9 divided by 1 over 27. Divide by 1 over 27. Divide by 1 over 27. So now we just need to get the value of R. So R is gonna be R is going to be 1 over 9, 1 over 9, right? Multiplied by 27, 27 over 1. All right. So now simplify. So R is gonna be 3. Therefore, R is equals to 3. The value of R is 3. So now we have to substitute in this equation. Sn is equals to A into R to the power n minus 1 over R minus 1. So we're substituting in that equation. All right. So now let's substitute. Let's substitute the value of A in this case. is 1 over 81. So the value of A (1 over 81) is 1 over 81. That is our value of A. Then R. So what is our value of R? R is 3. R is equals to 3. And what is our value of N? The question was saying use the formula to find the sum of the first 7 terms. So N is equals to 7. N is equals to 7 minus 1 over R. R is equals to 3. So you just use the calculator. So that will be 1093 divided by 81. Divide by 81. Therefore, Sn is equals to, in this case, S7 is equals to 1093 divided by 81. 1093 divided by 81. So we're not told to leave it to so many decimal places. So we can just say the answer is equals to 1093 divided by 81, because we're not told to round to how many decimal places. Divided by 81. So this is our final answer. Alright, so now I'm gonna give you a task. Alright, so just completed this problem. Now I'm gonna give you a task to complete. So here, calculate we have this sigma notation. Okay, calculate. We have 85 here. Then here we have k is equals to 4. K is equals to 4. And we have 5k plus 2. All right, try and solve this problem. Okay, try and solve this problem. I'm gonna give you at least 3 minutes. Try and solve this problem. We have the sum of 85 terms and k is equals to 4. Then we have 5k plus 2. So try and solve this problem. Just I'm giving you just only 2 minutes, 2 or 3 minutes. Hello? So we are left with 2 minutes, 2 minutes to complete this problem. Okay, you are left with 1 minute. You can send your answer or script, take a screenshot via WhatsApp. All right, thumbs up. So now let's do the corrections. Okay, here we have this expression. So here we are told that k is equals to 1. K is equals to 4. So now we have to get the first term. So tk. So tk in this case is tk. Tk is equals to 5k plus 2. So now you want the value of t1 because you want the first term, that is the value of a. Therefore, t1, first term, t1 is equals to 5k, that is where there's k, we put 1, is equals to 5 into 1 plus 2. So now the value of a will be 7. The value of a will be 7. Then now you must get the last term. So the last term in this case is 85. That is our last term. The last term is 85. So we'll have T85, T, T85 is equals to 5 into 85 plus 2 is equals to, so it's going to be 5 multiplied by 85 plus 2, so it's going to be 427. 427. So we have two formulas. So the first one is Sn. Sn is equals to n over 2 into 2a plus open brackets n minus 1 times d. So this is the first formula. So the second formula, we only use it if we have the last term. We only use the second formula if we have the last term, and in this case we do have the last term. The value of the last term is equals to n over 2 into a plus l, right? So now we're gonna use the last term because it's shorter and quicker, because we have the value of the last term. So now let's substitute. the value of n, in this case, the value of n is 85. So we can just say k. So the value of k is 85. 85 divided by 2 into a, the value of a is 7. 7 plus the last term 427. 427. All right. So our answer will be SK is equals to 427 plus 7, that is 434, then multiplied by 85, then we divide it by 2. So SK will be 18,445. So that will be that is the value of SK. So remember that the bottom variable, it can be k, it can be n, it can be I. It does not mean that it should always be 1. In this case, it was 4, but on our previous examples, it was 1. So you know that this one always changes, and this one at the top, the n at the top, or the k at the n, it will represent the last term. Then now we have Tn, in this case is Tk, so we have Tk. All right. So I'm gonna give you another problem. I'm not sure if you were connected when I was doing the geometric series. I'm not sure if you're connected. So I'm gonna do an example in case we're not connected. So now we have this expression. Number 4. So here we have we have 7. Then we have n is equals to 3. N is equals to 3. Then we have 2 times 3 to the power n minus 1. 2 times 3 to the power n minus 1. The power n minus 1. Okay. So evaluate this or calculate this sigma notation. So what we need to do here, as you can see, this is a geometric series. It's a geometric series, this one. So which means you're gonna apply the formula for the geometric series. The formula for the geometric series, Sn is equals to a into r to the power n minus 1 all over r over 1, all over r over 1. Okay, then now we need to substitute. First we need to get the first term, that is the value of a. To get the value of a, we use this. So remember, when you're given a sigma notation, so we have something like this. So we have something like this, that this is n, that n on top represent the last term, n at the bottom represent where the term will start. In this case, it will start at 3. Then this expression represent tn, but now tn in this case is 2 into 3 to the power n minus 1. So now we already have the expression tn is equals to 2 times 3 to the power n minus 1. So because we want to get the first term, that is a, so here we're going to say t1 is equals to a is equals to 2 times 3 to the power n minus 1. So we put here 1. So it's gonna be, so tn will be equals to 2. How? We said 3 to the power 0 is equals to 1. Then any number multiplied by 1 is equal to that number. So we have the value of a. Now let's find the value of r. So in order to find the value of r, we must get t2 at least 2 terms. We only just need at least 2 terms. So t2 is equals to 2. So here we'll have 2. Then t2 is gonna be equals to 6. We're gonna be equals to 6 because we said 3 to the power 2 minus 1, that is 3 to the power 1. Then 2 times 3 is 6. Then now let's get the value of r. R is equals to successive term divided by previous term. Is equal to successive term divided by previous term. In this case is 6 divided by 2. Therefore r is equals to 3. Then if we got the value of r, we can use this equation, this formula, because we have the value of r. So we have here Sn is equals to a. What's the value of a? The value of a is 2 into r. What the value of r? 3 to the power n. So the value of n will be 7. N will be 7. The value of n will be 7. The last one will be 7, not 3. The n is equal to 3 represent that the terms, they start from number 3. The terms start from number 3 and end at number 7. So here we will put 7, the one at the top. Always put the one at the top. Minus 1 over r minus 1. So the value of r is 3 minus 1. So you just put all of this in a calculator. So here we'll have, so this will become 2. This will become 2. So, and these 2 will cancel these 2, right? So Sn, so Sn will be equal to 2 to the power 7. I mean 3 to the power 7. 3 to the power 7. That is 2187. 2000 is equals to 2187 minus 1, 186. So this will be the value of Sn. So we were calculating this sigma notation. So first thing, get the value of A and the value of R, because this is a geometric sequence. So you get the value of A and the value of R. Then once you get them, you substitute now from this equation, or from this formula, you substitute. Then you put A as 2 in this case, then R as 3, then N should be the last term, the number at the top. Then you simplify. I hope you are following. So now I'm gonna give you a homework. I think we are done for today. Is there anything you want to ask regarding sigma? Do you have any questions? Okay, perfect. So I'm gonna give you a task that you need to complete. I hope you did I have not received your script for the previous homework I gave, because the reason we're giving you homework, so that you will know where you are standing, whether you are following or you need more clarity. So that's the reason of the homework. So if you do the homework, you will know where you are standing. If you don't do the homework, it's a proof that you don't understand. So I'm gonna give you homework. So I need you to send both the previous homework and this one. So thank you so much for participating. We'll continue again based on our timetable. All right, let's call it a day then. Thank you so much.